Okay, I now have the honor of introducing Andreas Mai. He's director of the Cisco Smart Connected Vehicles team. He's an expert in business and technology architectures for connected vehicles. And he's consulted automotive and insurance companies, service providers, and governments. He's the author of several studies, for example, on the Internet of Cars. And he serves on the board of the Connected Vehicle Trade Association, the Connected Car Council, of Octo Telematics, and of Coda Wireless. And he's also a member of multiple task forces of the World Economic Forum. So please welcome Andreas.
So first of all, I wanted to thank Carl Johansson, Rolf, and also James for inviting me to speak here today. I wanted to do this in Swedish, but I understand the majority here is not Swedish. Yeah. So tack för inbjudan. Tack för inbjudan här till Stockholm. Jag är hedrad att prata här på KTH. Yeah. So I did it. So what I just said for the other guys, yeah. Thank you very much for inviting me to Stockholm. I love it here. I am honored to speak here today. So who am I? So think of me as the guy from Cisco. Cisco, we have about a $50 billion worth of revenue. We have we spend about $6 billion per year in R&D, and have about a third of our 70,000 people working in R&D. You're out of luck. I'm part of the other 2/3. But what I wanted to talk to you about today is really my role in the context of what we heard here today from my previous speaker. So think of me as somebody who's standing in kind of on a bridge. On the one side, there's a lot of engineers. And on the other side, there's lines of businesses, of executives, who typically don't understand these engineers. You know, the engineers come to me and they say, oh my God, I have this greatest new router, I have this great new switch. And the business leaders come to me and say, we have this problem to solve, but we don't understand these guys there. So I'm running from left to right, from right to left, trying to build this bridge. But today, I want to talk about three things. Number one is disruptive innovation. Number two, I want to show you some money, because this is mostly what people are after. And number three is I want to share with you some of the technologies that we think are highly relevant to get this money. So let's talk about disruptive innovation. So yesterday I visited the Vasa Museum. The ship was much more impressive than this one. But about 200 years ago, these types of ships sailed between the old world and the new world where that I call home. And then one day the father talked to his son, and the son said, we need to innovate. We really need to do something to make things different. And after a lot of haggling, the father gave in, and they innovated. And here comes the new generation, and you know what's coming. Again, haggling between father and son. And son wins again, and they innovated again. Yeah, and then next generation, the son talks to father about, oh my God, they have these new engines, the steam engine. We really, really need to do something about it. And the father says, no, we don't understand the supply chain. We don't understand the technology. We don't have the people to do this. Go home, yeah? But the son is very persistent, and here's what happened. They built a hybrid. Yeah? And we all know what happened after all. This comes around, and it literally blew those old ships out of the water. And this is what we refer to as disruptive innovation, and that is something that is happening in an industry that is also very dear to this country, yeah, because you have a tradition in automotive. And what's happening in automotive, and here I reference for the first time the term Internet of Everything. Yeah, we heard a lot about the Internet of Things, so I thought, hey, we need to say something different here, right? So what is happening in the auto industry is they are connecting travel experiences. So they add to the vehicle things like, how do you make it easier to refuel? How do you make it easier for my customers to find parking? How do I make it easier to find a repair shop when something is wrong, and only if something is wrong? You know, these ominous symbols that pop up and, oh my God, what's happening? Yeah, nobody knows what's happening. Yeah, so you can reinvent this travel experience in a car. The second thing that is happening is a car is not alone anymore, and you here in Gothenburg or in Stockholm are very advanced in including all the other modes of transportation. Especially when we are talking about dense urban cities like in Shanghai, for instance, you cannot even breathe. Yeah, so if you add more traffic to the roads, it's going to be a disaster. And so multimodal transportation is an important one. Autonomous is the big accelerator of this. The big question that is out there, is it the incumbent automotive industry, or is it new players like Google, like Apple, like Next EV, like Faraday Future, that will reinvent this, that will bring this first to market? Well, and then we will find a hybridization between public and personal transportation. So think about a world where you have this type of a vehicle, a little pod, that takes you home or picks you up from home. And whenever you want to go from Stockholm to Gothenburg, it attaches to a hydrogen bus, and is recharged on the way to Gothenburg. And when you arrive in Gothenburg, you can continue your journey to wherever you need to be on a full charge. Things like this are in development. The next thing that is happening is insurance will turn into assurance, because suddenly if vehicles don't crash anymore, they need to rethink their business model fundamentally. And the last thing that is happening, and this is much closer to what you guys are working on, it's the exchange of data that needs to happen to make all of this happen, to make all of this really optimal and work efficiently. And I just picked up this other picture. It's the same story, so I will just build it up. So first, from building cars to selling travel time well spent. Second, the autonomous revolution. That's the biggest challenge for the auto industry right now. This will lead to us not owning but sharing a vehicle, and eventually also consider more other modes. But why I put this picture in last time was because you asked the question. You asked the question, kind of, what do we need to do differently in innovation and business models? And what we need to do differently is we need to move from a controlled, we want to control everything on the value creation side and also on the market access side, to something where we share the resources in terms of technology, and we share the cost to build out the basic infrastructure that is necessary to enable a lot of the use cases that I referenced earlier on. And on the other hand, we also need to be open to share access to our customer base. Yeah, so the automaker, if he gives access to the insurance industry to sell products to their customers, they suddenly have a joint goal to improve the premiums of their customers, but also to retain these customers. And you need to share data. Yeah? And the last thing is, for that, in particular in our industry, automotive and smart cities, it is phenomenally important that you have one infrastructure that you can share. It is simply unthinkable that you create all of these great use cases if you just say, hey, I just built my little network, or I just built my little sensor swarm to support some of the use cases that are of interest to me. And I will reference this a little bit later. So kind of the other thing that happened at Cisco is we actually elevated, we call it hyperconnectivity. Yeah, so it is really about connecting a lot of systems, first and foremost the product, the car. Secondly, then you need to connect it with the enterprise, because you can only generate the benefits of remote diagnostics, for instance, if you act on it very quickly. So you need to change the processes in the enterprise. The next element is you need to pass this through to your supply chain. Yeah, so that's the next frontier, when you connect your supply chain and become more agile in responding to things that may happen on the product. And the last and most important one is the value-added ecosystem. Yeah, I showed you in the beginning how important it is to connect all these other elements to create these great value propositions that we are all craving for. And that is what we refer to as the Internet of Everything, connecting things, connecting data, connecting processes, and connecting people, because people need to act on this. Without the human factor that we sometimes tend to forget, nothing will happen. And so what does it mean? In our world, it means we need to connect all these things here, the phone, the roadside, the car, the home, with enterprises, with the cloud. And all of this requires a lot of connections. We like that at Cisco. Fuel is or big data is the fuel of the connected vehicle, I sometimes say. But it's not only about the data that you get from the vehicle. It is very important to connect this data with other pools of knowledge, with the quality data from your operations, with the call center data where customers angrily call you, my door is not working, with your dealership where maybe there is a pile-up of repair orders for this particular incident. And this is kind of where you connect these pools of knowledge. And then you need to connect those processes. Yeah? So after you have all this data connected, you need to say, okay, if I want to drop off my car at Hertz at the airport, and I want to refill it, then the car tells me, hey, you could do two things, yeah? Johnny, you could either go to Hertz and you pay $100 to refill the car, or you could take a little stroll, and here are the three options that you have to refill it there. And then you do this, and while you are refilling, it is kind of automatically charged to your car, and when you arrive back at Hertz, they already know that you had refilled because all these systems are connected. That's an example of a process that makes our lives easier, but from a technology perspective, you know much better how difficult it is to actually achieve this. And the last thing is you need to connect people, because people need to act on this. Yeah? So if there is suddenly a realization that there's a quality issue, or if you think about the aspect of sharing assets, you need a human interface that actually makes this information available and allows you to make the conscientious decision, yes, I want to share this right, or yes, we should act on this particular quality issue rather fast to avoid damage. You know, let's switch gears a little bit and say, okay, that's all great. Yeah? Show me the money. And so what I've done is I have taken all these use cases that I showed earlier on, and I have said, okay, if I pile this up, and this is about 450 different impacts that I have aggregated here, what is the value at stake if we did all the great things we could do in transportation? And the interesting results is over the next 10 years, it's about $3.9 trillion, and that's a discounted value. Most of it in Asia Pacific, a little bit in Europe, a little less in North America. So that's a ton of value, but it is kind of, it crystallizes the importance of what you can do with all the great technologies that Rauf and Giovanni and Rudolf and others have talked about. Where are the key use cases? Interestingly, if you distinguish trucks and cars, it's primarily intelligent transportation systems for trucks because they are on the road so much, so the inefficiencies hit them over proportionally, and it is the connectivity aspect of it. Less than truckload, 25% of trucks running empty on roads, so if you have connectivity and can help them fill this idle capacity, it's a big impact. For us, in driving in a car, it's really the advanced driver assist system, which prevents a lot of crashes, but it is also mobility as a service because it makes mobility mobile for millions of people, as I will show you in one of the subsequent slides. The biggest winner is overall is society, because we also segregated it, who is going to make money, who will, or where will we create value, and where is value migrating to other stakeholders. Yeah? And the interesting thing is, if you look at it, auto is still the biggest winner outside of society, which is the bigger block. Owners and insurers are the next ones, and then the ITS industry is the other one. On the negative side, it is very clear that the drivers will lose most of all of us because we won't need drivers anymore. That's the unfortunate truth, but I will show you that the creation of jobs is much, much bigger than the jobs that we lose. This is also interesting. So we can prevent globally, based on all the studies that are out there, how many crashes can you actually prevent with the various technologies, 18 million crashes. We can prevent 9 million people that are injured, from getting injured, 700,000 lives. Yeah? But the other important aspect is time. This is over the 10-year span, and this factors in the penetration rates of the various vehicle types. We can save 230 billion hours of time, and that's a lot of time. That's 130 million work years, and that's 25 million years, or 380,000 lifetimes that we spend just in traffic for its inefficiencies. If you increase the penetration just by 1% point, the impact is significant. Yeah? So the more the governments can do to increase this penetration of vehicles, the effects are tremendous. But time, let's talk about time. Time is the only thing, the only good on our planet that nobody can give us away. So the time that you spend with us here today, nobody can give you back. And we spend an average in North America more than 500 hours in our cars. 500 hours. Yeah. That's kind of, if you spread this over the lifetime, it's about a pregnancy. It's 9 months that we waste in traffic. And it's just the inefficiencies. And if you then go into assisted driving, you can do much more things in your vehicle. So that's interesting, yeah? But you need to obviously check, okay, how much can the people do without getting too much distraction? But ultimately, if you have the autopilot, the value of that time that we spend in North America per year is about $3,400. That's the value, like if you do a time study, what do you do during the day? You sleep a little. You watch TV a little, and you work a little, and you shop a little. And if you put a value to this, this is the amount of money. So that's the value at stake for every vehicle we put on the road that is autonomous, in North America at least. And saving fuel. Yeah, so the fuel that we can save would spend 1.4 times the equator. That's a lot of fuel if you put it into trucks. And it would save about 1,000 supertankers. And this is about the scale. Yeah? So the Nock Nevis is the largest supertanker ever built, and you would fill 1,000 supertankers or over 10 years or 100 per year. That's the amount that you would save. For 1%, and that's also interesting, if you increase, again, the penetration of self-driven vehicles in particular by 1%, you would waste 60 billion liters of fuel. The reason is, if I had a car and the car drives me to work, the car would go back empty, would take my wife to work, would come back empty, and when my son finally gets up, he's a student now, then it would take him to university. So it has 3 empty halls, so to say, and that's why the mileage overall increases, which bears the question, well, if we have autonomous vehicles, we better make sure that these are electric vehicles. Yeah, because otherwise the emissions are going to skyrocket for the reason of these empty miles. And now let's talk a little bit about mobility as a service. We always look at it from the myopic perspective of where we live. Yeah, we can afford a car, so what do we need this mobility as a service for? But if you look at it, the interesting thing is you make millions of people mobile, actually more than 1 billion of people, if you apply the general models that people work with, if you have only 7% of the vehicle population that is mobility as a service. 1 billion more people. And there's a tight correlation between the GDP and the miles driven in a particular country. So if you make those people mobile, the economy is going to benefit from that. The other news is you will create about 40 million jobs over that time frame. So if you translate this into, with a very low elasticity factor with the relation of GDP to jobs, 0.33 is the consensus here, you're creating, for each dollar GDP, you create 1/3 of a job. You are talking about 40 million jobs that we can create. And that is why it is absolutely important to work on this topic for every country, particularly if it has a history in the automotive world. And The interesting thing of this story, and this concludes this money part, is it varies across regions. So we have done this for various regions, and given that there is different crash factors per region, given that there is different pollution factors per region, different penetration factors of the various technologies, how they pick up, so you won't find many autonomous cars in the Middle East. You have a significantly different profile as to what policies you should be driving in your country, in your region, to make all of this real. The network, and that's what we like at Cisco, is a key enabler for all of this. That's the last part of my talk. So what are the key enablers? And I have to say, I was sitting in the audience, and then all the speakers before me, they talked about these great technologies, and it was piling up. Oh my God, he talked about this and that. So bear with me. Some of these things are repetitive, but I tried to go through these very quickly. So first, I think the biggest challenge is you need to connect multiple data planes: the public internet, the enterprise internet, the ominous Internet of Things, and then the network of things, because some of those things have a network in itself, like a car. And there are fundamental challenges that need to be overcome in a car as well, as will have to be overcome in industrial plants. And to actually make that happen, I see 6, oops, where's this? Hang on, did it already build up? Okay, I see 6 key technologies. Ubiquitous connectivity, fog, I just renamed it a little bit. The end-to-end security is very important. Smart and fast data. Application and network integration. And lastly, the SDN and NFV that we talked about earlier on. But what very few people realize is that we will have more congestion in our networks than on our roads. We are expecting just from the mobile phone about 192 exabytes of data percolating in our wireless networks. That's a ton of data. And estimates, if you add the cars to it, go from as little as 1.5 gigabytes per month to 24 gigabytes per hour of data that is being produced in autonomous vehicles. We simply cannot afford to transport so much data. So we need to be very, very smart about what data to transport. But that makes this aspect of ubiquitous connectivity extremely important, because you cannot afford that an autonomous vehicle is suddenly not connected. And people will just do other things in autonomous vehicles. They will watch video, 70% of the network load. And so what we started to do is work with cities on the infrastructure that not only supports the city services that cities want to deliver to their citizens, but also creates offload capabilities for this network load. So some of the cities approach us, oh God, we have this great fiber network, and we connected all our light posts with a fiber network. And so now we want to talk with you, Cisco, what we can do with this. And this is the point where Wi-Fi offload suddenly becomes an important, interesting use case for them. The other element of this is the fog analytics I talked about, but what we also concluded when we did a number of these projects with cities is that single use case perspectives will not deliver the business case that you need to actually deploy the infrastructure that is necessary to even support one of them. And so we created this platform that has a shared infrastructure, primarily also deploying Wi-Fi. It has a common data layer that allows you to exchange data between the various domains that are currently extremely siloed in cities. Energy, from waste, from parking, from traffic, it's all silos, it's different systems. And these are the use cases on top run by an operation center that we have focused on, because this is where most of the money is. But keep in mind, you can only do this if you do multiple of these use cases. So a single one will simply not cut it. We just bought Jasper, which provides global SIM card management and the global management of networks from a mobile service provider perspective. But when we are talking about ubiquitous connectivity, we actually also need to factor in the local situation of the vehicle. So we also have a solution where you see a vehicle that allows to sniff all the, let's say, available uplinks in the proximity of the vehicle and decides on which one they can use for which particular use case or application. That is very important if you want to approach this with a kind of, you never fail, you always are connected, you never drop a package, you always have a redundancy where you kind of transmit this information. And here kind of, we also have investments in other companies like Meraki or Venium or Coda Wireless, where you can see kind of other uplink options. So if 4G, 3G fails, you would just switch over to another uplink, and you have replicated the traffic before, so you never would lose a package. Yeah? If you move further to the right, if we are talking trucking is kind of driving in very remote areas, in Sweden, in North America, so you cannot just simply rely on a terrestrial network. You have to have a backup plan. And ultimately, visual light communication, Li-Fi, in other words, is also kind of coming on board with the first commercial applications. And I think, especially in cities, it's an interesting field of studies. Moving on, I can do this very quickly. So that's the kind of the crunch points why we need fog. We at Cisco, actually, a gentleman called Flavio Bonomi coined the term. We said, okay, everybody's talking about cloud, we need to find something else, so let's talk about fog, which is much closer to the devices. And the reason for this is with all this traffic coming towards the data center, you have these choke points. You need to distribute both compute as well as storage capacity to overcome this dilemma. And if I move on, it's really about turning the traditional IT model upside down. So essentially, you create the fog, and you move the code, the rain effect as I call it, downstream, closer to the device. And here is kind of the debate is on, okay, what is fog? Is it the edge or is it the end device? And I think eventually it depends on how intelligent the end device can be, because some of the compute, for instance, for remote diagnostics on a vehicle can obviously be done on a vehicle. And the edge can do a little bit more, and the cloud can do most. Yeah, but you need a system that smartly decides what to best compute where, what to best store where, and this is where I found your work extremely relevant and interesting. And the other thing is data moves upstream. Yeah, but you need to be smart about that. We just heard the amount of data that is just hitting our networks. It's just not going to work the way we did things in the past. So you need to be really smart about what data to transport where and where to store it. Yeah, and you saw this. It's essentially the illustration in a different way of what we saw before. The interesting part here is you need to have on the edge the ability to really be smart about how you sense things, how you control things, and how you correlate things that you learn there. And I will give a very good example for fog computing subsequently. The hacker community. Yeah, so there's actually an industry out there that is worth $500 billion to $1 trillion that makes their money by providing each one of you who might be interested in the tool to do certain hacking jobs. The car is just coming along. But if a car is hacked, yeah, there is lots of studies out there from very reputable institutions also. This is dangerous. This is life-threatening. So we better make sure that we do this right. And this is just kind of another example where integration is a key element. So this is the journey of kind of Cisco has acknowledged the fact that we cannot build everything, invent everything in-house. So we also buy a lot of companies. And this is just this journey in the security realm. What have we bought? But that brings a tremendous complexity with it. And so what we created is a layer in between that allows you with a single protocol for the access, but also a direct access control interface to make sure that all the traffic in our network is monitored, that everything that goes in is known, everything that goes out is known. And then we created APIs to existing tools, because our customers have all these great tools and they want to deploy them. And with this API, they can continue to use these tools and create a kind of much, much higher level of security. What does that mean for automotive? So the problem in automotive right now is we have this lead engineer that says, hey, I just found anomaly detection. Ta-da! My car is secure. And then on the other side, we have the CIO who says, oh my God, I'm fighting with digitization. I have all these problems. I need to connect my partner ecosystem. And eventually that means that we need a chip to cloud to partner ecosystem security approach. Because an intrusion can also happen in Pandora. It can happen anywhere where somebody is allowed to transport files into my vehicle. And that's why we need this holistic approach, literally from the chip of the vehicle to the partner, how we connect them and how we make sure that the partner provides security. So from a perimeter perspective, we are talking about an advanced security system on the vehicle. This is where the industry is right now. The next evolution is you need to continuously report, is there anything fishy happening on my vehicle? And should it be happening, you need to have a remediation strategy where you also on a continuous basis provide updates to these ominous software packages that sometimes are also not working properly, or the applications that sometimes are not working properly. Then you need to have a secure IoT enterprise infrastructure. And the way at Cisco we approach this is we look at the context. So given that everything goes through our network, as I illustrated earlier or before, whenever an anomaly happens, you need to be able to contain this without compromising the working of the entire system. Yeah, so you need to basically quarantine. Let's say somebody hacks into my computer. You need to quarantine my computer so I can still continue to work. But you need the context of what is happening. Where does the threat come from? What server is attacked? What are they trying to do? And the last layer is you need to connect that with your external ecosystem. As I said before, you need identity management. Who has what access to what type of system? So that you always kind of limit the damage. And the ultimate question here is this a problem? And that's really something I think the academia can help us a lot to work on. Is this something that we as a company can solve ourselves? Is this something where we as an industry, in my case automotive industry, need to collaborate? Or is it actually topics that go cross industries, where you can apply the same tools to different industries and problems? And this is really, and I'm just picking this, that's why the one is there, 2 examples of why fog computing and security are very, very relevant. So you actually have the possibility to use these decentralized systems to do some of the heavy lifting in security that some of the dumb devices or the compute power on these devices are simply not capable of doing. So what you would do is you would manage security credentials, you would authenticate some endpoints, you would protect endpoints, you would establish trusted relations between those devices. You could do some updates there. Yeah? So the notion of, I shouldn't call it because it's an oxymoron, viral updates, yeah, where you pass on subsets of updates between devices. And you can also monitor and report some security infractions. Another example, and that's why I picked up on a project that I saw upstairs, it's really this, I call it crowd attestation. The use case upstairs was more on social media, but what these devices could do, they could actually become an authentication authority for kind of figuring out whether some of these systems are actually doing things they shouldn't be doing. So they know what is happening in their proximity, and if something is coming up that is fishy, they could actually intervene. And they could also do hierarchical attestation. So that's kind of from a security perspective, I think one of the most perfect use cases where the work that Rauf was presenting has high applicability. Then big data. Yeah, so everybody talks about big data, and it's actually an industry that is emerging. And I see 3 waves that this industry will evolve. So we are in wave 1. So we have siloed information, we have a reporting plane, so things are reported after they occur, and we have a lot of people that are data keepers. Yeah, no, you don't get my data. Yeah, so you have all these great silos and nothing happens. The second wave is you share this data intra-company. So you move also from a reporting to a more action-oriented approach, and data is made available under certain conditions. So only if you need it, only if it is used in that context, you can get this data. And the last wave, and this is where everybody is thinking about big data, the last phase, which is much more complex to achieve, is where you share data in an ecosystem, so outside of your 4 walls of the enterprise, where you move from kind of action to sensing. So you have the smarts, the deep learning capabilities to actually bubble up the things that are relevant and not waste too much time with the other big data elements. In this way, you create a market. You exchange data for value. Yeah, and that's the ultimate goal. But here's the problem. Especially in Europe, we sometimes stand in our own way. We did a poll on kind of 1,000 people around the world, and where we asked, would you share personal information and preferences for more customized experiences? And the interesting result was, if you go to the emerging world, people are happily willing to share the data. But if you go to Europe, and particularly if you go to my home country, it's terrible. They just don't want to share the data. And there are good reasons for this. I'm not debating this, but there is an industry, a multi-billion-dollar industry emerging that makes their business with data. And if we make it so difficult to participate in this revolution here, we will stay behind. It's a challenge. But data also requires, or the analytics aspect of it, requires an intelligent network. So traditional analytics, we were fine, hey, if we can get the results in days and hours. Yeah? So we had like structured data, traditional warehouses. Today, we are essentially unstructured data and big data storage, so that's where the cloud comes from, that's where we all feel comfortable with our great capabilities of cloud. But what we are moving towards is really real time. Milliseconds, seconds, data everywhere. We need to virtualize data, and we need to have an intelligent network that is capable of ingesting all of this. And so we have a tremendous amount of data growth. We want speed. We want real-time insights, and we obviously kind of are striving to do some of that on the edge. We just acquired a company that happened to have won the Frost & Sullivan Innovation Prize that does exactly this. Yeah? So fast query response is relative, as I call it. So if you compare the different systems here, PathStream is capable of being 10 times as fast as the fastest competitor. And that is real time. And the way they do this is not only fast, but it's also kind of conserving bandwidth in our networks, because kind of this is the traditional setup. You have the central analytics intelligence in the data center, but what PathStream does is they have little clients, very, very thin clients on the end devices or even on the edge of the network, and they just fish out the relevant data. And they also do this with these big, big data stores. So the other elements that are, let's say you have a historical database that you compare this with, they do it the same. So they have an index that allows them to smartly detect those relevant from those irrelevant devices, and that is fast data. Yeah? And that's also what I refer to as smart data, because you need to develop the smarts to do all this. And then we are here on the, we heard a lot about the integration of apps and APIs. This is something that we work on at Cisco quite extensively, and what we have done is we have created a platform that allows you to work on the application plane, the control plane, and the data plane, and does two major things. So we have created APIs that go northbound, so towards the applications, and southbound towards the infrastructure. To get a tighter integration, it's essentially the Apple model applied to networking. To get a more tight integration and higher performance of the network. So essentially, kind of this is the Cisco automation and integration platform. What we do is kind of, you see three types of integration elements here. Yeah? You see app to app, you see infrastructure to infrastructure, and then app and infrastructure, which would allow you, in your case, for instance, to support use cases. You have this model where you, in Venice, if I recall correctly, where you said, okay, what is the cost of higher performance? You could actually tie it to the application and measure, okay, if this application goes down, what is actually happening in the world where it goes down? Yeah? This allows us we have these infrastructure apps, we have the network services apps, and we have the integrated apps that do both. Yeah, so we go to kind of really a length to integrate any critical apps with the network capabilities so that we actually have, and that's the page here, a bandwidth on demand, that we have intelligent service provisioning and scheduling, that we have intelligent traffic steering, and intelligent network-aware workload optimization. Yeah, and that's why I was so interested in connecting Rolf to see how things that we do relate with what you guys are doing in Waterloo. And that brings me to the end of this presentation. Just 2 slides left, so bear with me. It's like a little bit like a video. Yeah? So these are the 6 elements that we talked about. Yeah, so we talked about ubiquitous connectivity, which I think is the first must-have criteria. The fog, which you called SAVI, is that right? SAVI, yeah. The end-to-end security aspect, which I think I haven't seen much about, but I picked up on at least 2 projects up there that were related to this, but I regard this as one of the big unresolved mysteries in this ominous world of IoT or IoE. Smart and fast data, we talked a little bit about that. Yeah, so it's not just about the processing capacity in the cloud, bigger machines. It is about kind of how do we manage this avalanche of data in a smarter way. Yeah. Then app and network integration we talked about, and eventually we are also talking about both things that we are very actively working on, the SDN aspect and the network function virtualization, which takes this app and network integration to the next level. And so when we talk about Cisco, it's kind of, you need to connect all these systems here. And our role here is really kind of to provide the ability to do this in a very efficient way, to integrate all these systems, but also to automate a lot of these processes. Because some things that happen there are simply beyond human intervention capabilities. Then the virtualization aspect and the security, because after you have connected all of this, and this is why I think security is the big elephant in the room, people can intrude. If they intrude in one end, they can go into your system. And that's why you need security, to build security essentially into your architecture from day one. And then I pulled this chart from another presentation. That's why I asked the question about the connected stadium. We actually have, and this is the Dallas Cowboy Stadium in the United States, where we have created a stadium experience, where we have connectivity provided to all people in the stadium, where you can use your Wi-Fi network in the stadium to also decide which angle, whatever you want to see, a particular scene again. So you can customize what you see on your device while you are in the stadium, either on your mobile device, but that's the link to our mobile service providers. We also do this, to our service provider customers, we also do this at home. So you think about you sitting at home and you can decide what you want to see about the game. But that's the only page I could end with fog, because it remains foggy. But I wanted to make you aware of this open fog consortium that one of my colleagues has created. A lot of very reputable companies are already members. And I truly regard the work of Raouf and fog, we call it, you call it, Savi, as one of the must-have capabilities in a world of IoT or IoE, whatever you want to call it. Thank you very much, and I'm happy to answer any questions.